Let's take a look at warm-up number 10. Number 1 says, write an equation to represent the situation. So that's the 7th grade, or really the 6th grade part of it, is writing an equation here. And then solving it, you probably could have solved a problem like this, maybe 4th or 5th grade. But you've got to make sure that you write an equation. All right, so brand A cost $46.29 and brand B cost $42.89. What is the difference in the cost of brand A and brand B? Anybody have an attempt at an equation? Who solved it? Who got an answer for the difference? Noelle, what did you get for the difference? Okay, how'd you do that? Okay, so you subtracted because it said what's the difference. And this is kind of like those problems, the difference problems we've been doing. And some people have been saying if it said what's the difference between -2 and +31. And some people were saying, well, the difference is one's a negative and one's a positive. Or one is lower and the other one's higher, right? So difference mathematically means to subtract. So let's do this part and then we'll go back and we'll write our equation. Sometimes it's easier to solve it and then figure out what that equation was. So $46.29 minus $42.89. 9 minus 9 is 2 minus 8. Can't do it, so we need to borrow, make that a 5, and this is a 12. 12 minus 8 is 4. 5 minus 2 is 3. So our answer is, the difference is $3.40. Make sure word problems have what? Words in the answer. The difference is, $ comes before the number, $3.40, period. But now we have not done yet the real task of the problem, which is writing the equation. So remember, if this is a subtraction problem, our equation has to be the inverse operation. What's the inverse of subtraction? Addition. So we've got to figure out what it is we are going to add. So we know that one number has to be over here, and one number has to be over here, and we have to have something adding to a variable. So what number do you think goes over here with adding to the variable? Is it the 42, and then we're adding something and we get the 46 and change? Or is it the 46 and we're adding something and we get the 42 and change? Which number do you think? The $42 or the $46? I mean, mathematically, if we're going to add something to it, which one's the one that makes sense? The 42. $42.89. That's the lower priced one. Then we're adding to that the difference, which is what we solved for. This was the difference. This one was the lower price. So if we take the lower price, we add the difference, then we're going to equal what? $46.29. Does that make sense? So then if we were to do this, what we do is this is like a balance. We subtract $42.89 from here, $42.89 from here, and then it looks like this problem, right? Does that make sense? Okay, this is a struggle for a lot of us still. But we should have learned this in 6th grade, because in 7th grade we're going to have to learn to do 2-step equations like this. So we really got to master these 1-step equations. Are there questions about that? All right, let's look at 2. Solve the following equation. 17x equals 102. What's the relationship between the 17 and the x? What's the math that's happening? Raleigh? Multiplying. So if it's a multiplication equation, how are we going to solve it? What's the inverse? Division. it should look like this. Divide by 17, divide by 17. Stop using that division symbol. You're not in 4th grade anymore. It has to look like a fraction. 17 divided by 17, what does it leave you? Leaves you with 1. So 1x is just an x. That goes away. 17 divided by 17 leaves you with 1x. Do we have to put the 1 in front of it? No, that coefficient in front of it tells us how many x's we have. So if you put a 1 in front of it, it's not wrong, but it kind of looks like you don't know what you're doing, because this literally means 1x. Equals, now we've got to do some division here. 102 divided by 17. So I know that 20 times 5 is what? 100. And this is lower, and this is higher. This is lower than 20. This is higher than 100. So I think it's going to be more than 5. What should we try? Let's try 17 times 6. Ooh, that looks like perfect, right? 6 times 1 is 6 plus 4 is 10. 102. So what's our answer? X equals 6. Everybody good? All right. Solve and graph the following inequality. Inequality. So that means instead of it being an equation with an equal sign, it has an inequality sign. That just means a greater than, equal to sign in this one. We still solve it the same as if it was an equation. If this is x minus 15 is greater than or equal to 8, what's the opposite of subtracting 15? Add 15 to both sides. You're left with x. That makes a 0 pair, so it goes away. Greater than or equal to, what's that, 23? 23. X is greater than or equal to 23. Then you learned last year to graph this on an open number line. So in the middle, we're going to put 23. Put a couple numbers on each side of it. All right. Does this include 23? Could x be exactly 23? Yes, so it's a closed dot because it includes 23. Closed dot. And it's all the numbers greater than. X, if x is greater than or equal to 23, could x be 24? Is that greater than 23? Yes. Could x be 25? Could x be 1,000,000? Yes. So you've got to draw an arrow that goes in the greater than direction. It's all of these numbers greater than or equal to 23. Make sure that we can see. You do not hover above like you do in a number line adding and subtracting integers problem. It goes right on the number line. Could x be 23.5? Yes, because it's over here, right? It's halfway between here and here. It's anything on the number line. It could be 23.00009 because that's a little bit bigger than 23. Do you remember doing these last year now? Yes. Okay. Write an inequality to represent the situation. That means instead of having an equal sign like up here, we have to have a greater than, equal to, less than, equal to, greater than, or less than sign. So that's our task, is to actually write an inequality. So again, we might solve it first, but we'll see. A theater rents their space for $300 per night. If the company charges $9 per ticket, what is the least number of tickets that must be sold in order to make a profit? The least number sold to make a profit. So what is a profit? Anybody know what that means? Evan? You make money. So first, in order to make money, they have to collect at least $300, right? Because at $300, they're going to get that money, and then they're going to be able to pay for the theater, right? So if they make $301, how much profit did they just make? If they collect $301, what's their profit? $1. If they sell $310 worth of tickets, what's their profit? $10. So, do we have to be more than $300 or less than $300? We have to be more than. Could we be exactly equal to $300? Is there a profit at exactly $300? No. Does it have to be more than $300? Yes. So I think that's our inequality sign. Is that our inequality sign? Greater than? So whatever happens, it has to be greater than $300. We know that. Correct? Did you see the way we reasoned through that? So sometimes when you're having trouble with problems like these, you have to do that math self-talk with yourself, like, what does this mean? What's a profit? And you have to kind of go through those situations with yourself about when you have a profit. All right, so they're going to sell some tickets to make this money, correct? And what are they going to charge? $9 per ticket. So does anybody know what math that looks like right there? What is it? Is it going to be division? Are we going to split the tickets by $9? Or are we going to say we sell one and it's 9, we sell another, that's another 9, another, that's another 9? So that looks like addition, but it's repeated addition. And repeated addition is really what? Multiplication. So we've got to have a multiplication problem. So it is $9 per ticket. And how many tickets do we have to sell to make more than $300? That right there is the 6th grade work of this problem. That's not easy. I'm going to tell you right now, I know that's hard. I used to teach 6th grade and 7th grade at the same time. That is a hard thing for you to figure out sometimes. We'll practice it a lot and you'll get better, but I'm not doing that and saying that that's an easy thing. All right, so if this is a multiplication problem, how do we solve it? How are we going to solve it? We can't multiply because we don't know what that is. What's the inverse of multiplying? Divide. Divide by 9, divide by 9, and that means our tickets must be greater than, so now we've got to do some math here. 300 divided by 9. 9 goes into 3 0 times. 9 goes into 30 how many times? Is it 3? 9 times 3 is 27. 9 goes into 30 3 times. 27. Ooh, what's happening here? It's repeating, right? Oh, that's going to be another 3. And so, is that ever going to end? No, it's a repeating decimal, so it's never going to end. So, the tickets must be greater than, you could say 33.3, or you could say 33. Why do I not have to have that decimal? Can you sell part of a ticket? No. And so we just automatically know the tickets have to be, we have to sell more than 33 tickets. If we sold 33 tickets, we would be a little short of $300. If we sold 34 tickets, we'd make maybe $5. And then anything after that is just $9 more, $9 more, $9 more. Okay? So, do we need to have words? What might we say? It says, what is the least number of tickets that must be sold in order to make a profit? So, it's not 33 tickets. What's the least number that has to be sold? 34. If I come around and look at your papers or when I take them up, I should see these words on there. 34 tickets is the least number to sell to make a profit. Does that match our answer? Because that says 33 and this is 34. Does it make sense though? Because the tickets must be more than 33. So the next one up is 34. So you have to interpret that correctly. Ooh, this was a hard warm-up today. I thought it was super fun. Who else thought they were super fun? Everybody? Good. All right, questions? No questions?
Why are you so enthusiastic about it?
I love math.